Hello everybody. So what we're going to be looking at today are inverse trig functions. So we're going to split this up into two lectures. In this first lecture we're just going to talk about calculating values, and it's actually a very quick assignment. I think you guys could probably do this in maybe 20 minutes or something if you tried, maybe even less. So this first page here, you'll see I have a bunch of tables that I just wrote for you guys. All these are function values. So like, if you want to know what the values are for the sine, here they are in this first table here. And you should know these or be able to calculate them from the unit circle, right? Like if I say, oh, well, what's the sine of pi over 4? You should be able to go to the unit circle and just say, oh, well, that's actually square root 2 over 2. Right? And a lot of those you're going to be okay at if you have a unit circle. Others are harder, right? Like if I say, oh, well, what's the secant of 5 pi over 6? You wouldn't know that off the top of your head. And that's what this table is for, right? Like, okay, here's the secant. Here's 5 pi over 6. So what's the secant of 5 pi over 6? It's right here. Negative 2 square root 3 over 3. And yeah. So that's intended to help you just with this homework assignment and in general for calculating these. And again, your life will be easier if you use these tables. But for now, we're just going to ignore them so I can talk a little bit about theory, and then we'll jump back to these in a little bit. So ignore them for now. So let's talk about inverse trig functions. Now, something you might remember from, either this class, maybe not this class, I don't remember if we did it now, but in some class you learned about inverse functions. And so a fact is a function only has an inverse if it's what we call 1, that's a 1 to 1. Now the way you check 1 to 1 from a graph is the graph passes a horizontal line test. Now you're probably more familiar with the vertical line test. So the horizontal line test is the same thing, but it's a horizontal line. Very instructive, right? So the thing is that like a function that does not have an inverse would be something like this. So if you draw a horizontal line through this function like this, you'll see that it hits in 3 places, right? Horizontal line hits in more than one place. That means not 1 to 1. Not 1 to 1 means no inverse exists. Okay, whereas if you have a function like this, any horizontal line that you cross through here is only going to hit in one spot, right? Any of them we're only going to hit in one spot. So every horizontal, I'll abbreviate that way, line hits the curve in only one place. That means it is 1 to 1. That means it has an inverse. Okay, so that's great. What we want to talk about are the trig functions, if they have inverses. Now, something that's important to understand is that all of the trig functions are not one-to-one. And that's like really easy to see. If you look at a graph of any of them, right? Like let's look at a graph of the sine function. Right? If you cross this, if this is y equals sine x, and you cross this with a horizontal line, right? It actually hits in a whole bunch of places, right? Definitely not one-to-one. So that means it has no inverse? Question mark? Technically, yes. Sort of. Okay, so all of the trig functions are not one-to-one. Or rather, I could say none of the trig functions are one-to-one. So they're not one-to-one at all, none of them, because they all have that same issue, right? Because they repeat themselves as you go across as x. Like as the angle goes around the unit circle, you eventually get back to where you started, which means the function values repeat, which means it's not one-to-one. Okay, so technically they would not have any inverses, but we want them to have inverses. But we want to define inverses anyway. For all of them, anyway. Okay, so how are we going to do that? It's an interesting question. So what we're going to do is, in order to make it so that they do have an inverse, what we're going to do is we're going to restrict the domain of the function to a section where they are one-to-one. Okay, so this is how we do it. So to define inverses for all of them anyway, we do this by basically just restricting the x values. I'll say restricting the values just to a small section of the graph. Where it is one-to-one. So that's how it's done. Now, I'll show you how that looks, but we're not going to make a big deal out of it because we don't need it for what we're really doing. So, like the original sine x function, we already just drew it, but I'm just going to sketch it real quick. Right? Not one-to-one. But right here is pi over 2, and right here is negative pi over 2. And if you just take the section, so we're going to restrict domain to negative pi over 2 to positive pi over 2, then we get a different graph. Well, I mean, it's the same graph, but what it looks like is this. Right? And so this one does pass the horizontal line test. So this is still the sine function. It's just a little piece of the sine function after we restricted the domain. Then what happens is, to define the inverse, the inverse of the sine function, which we give a clever name to. We call it sine inverse of x. So that's the symbol for it. The inverse of the sine function, y equals sine inverse x. Or, and there's another name for it that you need to know, we'll say arc sine x is defined, or is, I'll say defined by just switching the x and y values from the function that we just drew. That's always how you get an inverse, by the way, is just switching the x and y values to get this graph. So if you switch all the x and y values, then you'll have pi over 2 up here, negative pi over 2 down here, 1 out here, negative 1 out here, that's I'm drawing it wrong real quick. Let's try to draw it right. Like that. Okay, so if you compare that, so if you compare the graph here of y equals sine inverse x, you'll notice that like the y values here, sorry, the x values here are the y values here, right? And the y values here are the x values here. So the shape is kind of reversed. It's kind of a weird mirror version of it, okay? There you go. So that's how you do it. And that can be done for each of them, okay? Each of the 6 trig functions. I'm not going to draw them all here. I'm just going to say that you could do it. So the summary of how to restrict the domains is as follows. Right? So sine x, which we just talked about, has to be x in negative pi over 2 to positive pi over 2. Cosine x, actually you need a different section of the graph to make it work out. You need 0 to pi. Tangent x is negative pi over 2 to positive pi over 2. But notice I'm using square brackets for the sine and the cosine and parentheses for the tangent. That's because I don't want to include the endpoints there for the tangent. Right? So I'm just writing that right now. And so there we go. So those are the restricted domains. So when you have the when you switch the x and the y values, then what happens? Sorry. So when you restrict the x and the y value, you restrict the domains and then you switch the x and the y values, then this is what the result is. So after switching x and y values, you have 3 functions. You've got y equals sine inverse x. The domain, now this is the domain of sine inverse. So like up here I said we restrict the domain of sine to negative pi over 2 to positive pi over 2. But that's the domain of the sine. This is the domain of the inverse sine. So the domain of the inverse sine is actually negative 1 to 1, and the range of the inverse sine is negative pi over 2 to positive pi over 2. For the cosine inverse, the domain is going to be negative 1 to 1 again, and the range, the y values, the range is the y values, the range for cosine inverse is going to be the domain of cosine. So 0 to pi, that should be square. And for y equals tangent inverse, the domain is going to be actually negative infinity to infinity. And the range is going to be negative pi over 2 to positive pi over 2 in parentheses. All right, so those are, like, that's just a little summary of domain and range, which you will not have to write down on the homework or anything, but that's a summary. Now the graphs of them, we already graphed sine inverse, right? So sine inverse is right here. I should do a better job. Duplicate. I need this back. Come on, let me pick it. Oh, that's useless. That just did I don't know what. Okay. Can I make it smaller? No, of course not. Okay, so that's just going to go off the page. Awesome. So that's sine inverse. Now, cosine inverse is going to have kind of the same idea, but if you look, the domain is negative 1 to 1, but the range is 0 to pi. So cosine inverse is going to look like this. So we're going to have negative 1 to 1, and so cosine inverse of negative 1 is going to be pi. This is pi over 2, and then there. And it has a kind of the same shape as the sine inverse. So that's y equals cosine inverse x. And then for tangent inverse x, I'm not going to draw tangent for you, but I'll draw tangent inverse for you. Tangent inverse does this. So the reason, if you look at the range of tangent inverse, and the reason we're not using square brackets there is because it never actually gets up to pi over 2. So you have pi over 2 there, you have negative pi over 2 there, and what the graph of the inverse tangent looks like is it goes up, and then as it gets closer and closer to pi over 2, it levels out. And same thing down here towards negative pi over 2. It gets closer to negative pi over 2, and then it levels out, but it never actually quite gets there. And so you can see that this goes out forever this way and out forever this way. That's why the domain is negative infinity to infinity, and the range is the y values. You can see it's stuck between negative pi over 2 and positive pi over 2. And so those are your functions there. Those are your inverses of sine, cosine, and tangent. Okay, now that's great. What you're going to be doing on, probably 80% of the homework questions is simply calculating an inverse. So the relationship between the inverse and the original one is as follows. So so here's how you calculate them. How to compute inverse trig values. So if, let's say, sine of pi over 6. Do you know what sine of pi over 6 is? Sine of pi over 6 is 1/2. Okay? That means that sine inverse of 1/2 is actually equal to pi over 6. So it's working backwards, right? So when you see this kind of question, if somebody says, find, I'm going to say cosine inverse of square root 2 over 2, what they're saying is they mean what theta gives you cosine theta equals square root 2 over 2. That's the same question. Okay, so like they're giving you the result and they want to know the angle. So they're asking you what angle. All right, and that's why I gave you all these tables at the beginning, because what you're going to do is you're just going to say, well, okay, well, I've got this cosine theta equals square root 2 over 2. Where is that? Where is the cosine theta equal to square root 2 over 2? So you just go to your tables, you find cosine, you find square root 2 over 2. Here's square root 2 over 2, right? They want you to go back to the angle. So what's the angle? Pi over 4. Right? So you look up the square root 2 over 2, and then you find the pi over 4. So the answer here is, you can say, so the answer, pi over 4. So what's cosine inverse of root 2 over 2? Pi over 4. Okay, and so you should be able to just do this for any of them that are in the list of tables, even the ones we haven't talked about. But well, we haven't talked about them, so we're not going to do it yet. But like if I say find tangent inverse of square root 3 over 3 negative square root 3 over 3, right? You're just going to take this right here, negative square root 3 over 3. You're going to go to the tangent table and you're going to find that value. And what we want is, what's the theta? So you go to your tangent table. Up here, we find the tangent. Was it negative square root 3 over 3? Was it this one? If it was negative square root 3 over 3, then it's negative pi over 6. Yeah, so it is negative pi over 6. Okay, and so that's what you're going to be doing 90% of the time on the homework. Now, the other task that you have on the homework is going to be just using a calculator. So they're going to say, use a calculator to compute. And what kind are they going to give you? They're going to give you stuff like, they'll say, use a calculator to compute. No, they don't say it that way. They say use a calculator to solve, they say, the equation in negative pi over 2 to pi over 2. Now the reason they're saying negative pi over 2 to pi over 2 is to make sure that, you know, your calculator can do it and everything's going to be fine with the answer. So that's to help you. And then they give you something like this. Cosecant theta equals negative 7 over 3. All right. Now, this is actually a little bit tricky here. So your calculator doesn't have a button for an inverse cosecant, so you need to know that. So your calculator can only do sine inverse, that's a sine, cosine inverse, tangent inverse, not cosecant inverse, cotangent inverse, and what's the other one? Secant inverse. Right? So it can only do the three basic ones, sine, cosine, tangent, not cosecant, cotangent, secant. So what they want you to do is they want you to say, well, cosecant theta is -7/3. But we know that cosecant theta is actually 1/sine theta. Right? That's a basic definition. So 1/sine theta is actually -7/3. So you can rearrange this a little bit. I mean, you have to use some algebra. One, if you bring the sine here up to the other side, then you have -7/3 sine theta, and then you bring this over to the other side, you have sine theta is -3/7, right? And maybe, maybe if you're smarter than me, maybe you can go from here, stop that. Maybe you can go from there to here, just by realizing that 1/the sine, well, no, like basically this. If you flip this upside down, you could flip this upside down and then get that. It doesn't matter. You need to be able to go from cosecant theta equals -7/3 to sine theta equals -3/7. Okay? You do that somehow. Now, the key thing is there's a property of inverses. This is important. So the key property of inverses is as follows. If you do f of f inverse of x, then f and f inverse cancel and give you x. Or if you do f inverse of f of x, they still cancel and give you x. Okay, that's a key property of inverses. And the reason that's relevant here, that's fine, you can be a weird shape, I don't care. So the way that's relevant here is we've got this, -3/7 equals sine, was it theta? Yeah, theta, right? But what you do is you're just going to apply an inverse sine to both sides. So you're going to get sine inverse -3/7 equals sine inverse sine theta, right? So we just put a sine inverse on each side. But on the right-hand side, look at that. A sine inverse and a sine. They're just going to cancel. So you're going to be left with just a theta, right? Due to that key property of inverses. The inverse sign cancels out the sine. Now this right here, how are you going to get it? Well, that's where you need a scientific calculator. You need to do sine inverse of -3/7. Okay, so you just grab a calculator here. I have one somewhere. Oh, there it is. There it is. Open up. Click to clear this. So you just go sine inverse. How am I going to get a sine inverse? Yeah, okay. So shift sine inverse, and it was -3/7, parentheses. I'm in radian mode, right? Radian, radian, degree. We're supposed to be in radian because they talked about -π/2 to π/2. Those are radians. So sine inverse -3/7. Enter. There you go, it has it. And they said on the homework they wanted 3 decimal places. So that's going to be -0.443 when we round it. -0.443. All right. And no matter what scientific calculator you have, you should be able to do it and get that answer. Okay? But you need to know how to find sine inverse. A lot of times you need like a second button. The calculator, so a lot of time you type second sine to get sine inverse. Okay, now if you use a website for this, you might be looking for arc sine. Remember when we said up here we defined them and we said they had other names? Well, I said one of them. I said, where is it? That's it? Yeah, here. Right, so I said that, arc sine. There's the equivalent of that for every one of them. So if you're typing, use a computer, you may want to type arc sine like that, or arc cosine, whatever, or arc cosecant, or arc cotangent, right, or arc tangent, you know, etc. I say etc. There's only one that I didn't write. I didn't write arc secant. But the point is that you can, if you're using like Wolfram, you don't want to use like that -1 exponent, because that's not really good for typing. So I would type like arc sine -3/7 like this. That's how I type it. And you see we got the value right there, which is exactly the value that we got on our scientific calculator. So there you go. I mean, that's not that bad. So let's look at some more. All right, here's another one that's a calculator. They say solve for theta in -90 degrees to 90 degrees. So they're giving you it in degrees, so that just means be in degree mode. Right? They don't say that, but you got to know. And they want tangent theta equals -4/3. Now, the reason you need a calculator is because the way we were calculating these by hand is we would say there's -4/3. So go up to the tangent table and look for -4/3. But look at the values that we have, right? Where's the -4/3? There's no -4/3 in the table, right? Because we only put certain numbers in there, not every number that exists. So that's why we need the calculator. So let's do this. Come back here. Tangent theta is -4/3. So how are we going to do this? We should remember how to do it. We're going to, I want a different color. Why is it that color? I wanted pink. Take tangent inverse of both sides. I don't have to rearrange because tangent, we can do a sine, cosine, and tangent inverse. We can't do the other three. So you have tangent inverse, tangent theta equals tangent inverse -4/3. So this is theta, and this is tangent inverse -4/3, which I'm going to use a calculator for. And the only thing to really be careful about is degree mode, right? Because they told me I was in degrees by telling me this. So again, I'm just going to use the scientific calculator. Well, no, I'm not, because I forgot. -4/3. So you just go here, shift, tangent inverse, -4/3, parentheses, but I got to make sure I'm in degree mode. Degree mode, enter. -53.1. Okay. And that's it. That's it. So again, let's just do one extra. Let's do one extra that we're going to use our table. So let me say compute arc cosecant. Oh, well, I can't, because I can't remember what the table was. I don't know what to put in the thing. Let's look. All right, cosecant, what can we do? (2√3/3). Let's do positive 2√3/3. (√3/3). Okay, I hope so. Otherwise, we're going to be in trouble. All right, so let's say we have to compute this and we want it exactly, right? So we're using the table, not a calculator. So arc cosecant. So remember, that just means this. Same thing. And what you're going to do is you're going to find this in the table for cosecant. 2√3/3. 2√3/3. So cosecant. Look for it. It's here. 2√3/3. The corresponding angle is pi/3. So what's the answer? Very simply, pi/3. All right, and really, you won't let me. Just won't let me do it. Okay, so that's how you do these. So all the problems are either this kind where you look it up in the table, or this kind where you do it on a calculator. There's nothing more complicated than that in this section. Okay, so I wanted to give you enough of the theory that you had some idea of where these came from, but all you're going to be doing is using these tables and using a calculator to do inverses. And remember, the idea is that they're giving you the function value and you're going back to the angle, right? Like when you do cosecant, 2√3/3, they're giving you the cosecant value and they want the angle. So you're working backwards to the angle when you do this. All right, so anyway, that's it for this video. So I will talk to you next time. Hope this recorded.